Today, we're going to have a look at fraction busters, how to solve equations with rational coefficients. How can we make our equations simpler in order to solve it? So let's begin with this equation here, 1/3 plus x thirds equals 10 thirds. Now, one thing that each term in the equation has in common is all have a denominator of 3. So, if we were able to find a way of getting rid of denominator of 3, then I believe we can have a way of making the equation simpler and much easier to solve. All right? Now, one thing you should know about each fraction, these are separate division problems. And each part, each term is being divided by 3. So, what if I did the inverse? Instead of dividing by 3, what if I multiplied each term by 3? So, what would that look like? That'd be 3 times a third plus 3 times x thirds. And that'd be equal to 3 times 10 thirds. All right, now let's simplify it. 3 divided by 3 is 1, so I'm left with 1 here, plus 3 divided by 3 leaves me with x here, and that's going to be equal to 3 divided by 3 is also 1, and 1 times 10 is just 10. Now, I have 1 plus x equals 10. Solve my equation. I will subtract 1 on both sides. And so this will give me x equals 10 minus 1 is 9. So I have x equals 9. Notice how we go from here to here. Back to regular whole numbers. And with that, I have a much simpler equation to solve than what I started with. All right? Have a look at here. Here I have 9,000x squared minus 6,000x minus 15,000 equals 0. Here I have a quadratic equation. What will these 3 terms have in common? Well, these 3 zeros will indicate these are thousands. But if I also look at here, I have 9, 6, and 15. 9, 6, and 15 have 3 in common. So, what if I divided each term by 3,000? Or 1 over 3,000. Minus and this will be minus 1 over 3,000 times 15,000. Now remember, 1 over 3,000 multiplied by each term is the same as dividing each term by 3,000, since that will be a common factor between 9,000, 6,000, and 15,000. Not enough room to write my 0. Equals 0 here. Now, let's simplify. 9,000 divided by 3,000, which will leave me is 3x squared, minus 6,000 divided by 3,000 will leave me with 2x. And then 15,000 divided by 3,000 will leave me with 5 equals 0. Now, to finish solving this quadratic equation, I'm going to go through and use the quadratic formula where I have A is 3, B is -2, and C is -5. In my quadratic equation, X will be equal to B plus or minus the square root of B squared minus 4AC divided by 2 times A. Substitute my values in here. That'll give me -2 plus or minus the square root -2 squared minus 4 times 3 times -5. All right, and that's divided by 2 times 3. All right, so we got X equals -2 plus or minus square root of -2 squared is 4 minus -5 times 3 will be -15, and times 4 gives me a -60. And of course, 2 times 3 is 6. And so this would give me now -2 plus or minus 4 minus a -60 will give me the square root of 64 over 6. And last but not least, the square root of 64. If simplifying, the square root of 64 would be 8. So X is equal to -2 plus or minus 8 over 6. And finishing this out, my two separate values will be -2 plus 8 divided by 6, which is, let's give me a -1 here, because -2 plus 8 is 6, and 6 divided by 6, actually that's a +1. And then, or -2 minus 8 divided by 6, which gives me a -10 over 6, or in simplest form, -5/3. So my solution would be 1 or -5/3. So in both examples, we were able to find a number that we can either multiply each term by or divide each term by in order to make our equation much simpler to solve. In the second one here, we reduce down our larger numbers to more smaller, more recognizable numbers in order to apply them to the quadratic formula to find our roots of our quadratic equation.